Obviously, something like the ability to circumvent an access control is a pretty serious exploit. It's one of the most fundamental things attackers like to do. How do we get around the fact that this resource is only meant to be accessible to authorized users? That is often the very essence of hacking. So let's take an example of where we can use a tautology in SQL injection to log in as someone else. Now let's imagine this. You go to a website, you log in, and these are the credentials you provide. As in the previous clips, I've put the untrusted data in red. So imagine this time it's a form on a web page. It's going to be an HTTP post. There's one field called username, one called password. We're going to pass these values. Now inevitably, this particular login is going to translate down into a SQL statement that looks something like this. Now there are a few things that I want to point out with this SQL statement. So number one is it's clearly just looking for an occurrence of a user with a username of John Smith and a password of password with an @ instead of an A. The reason it's doing a select count star here is it's just trying to find how many of these exist. And of course it should really only ever be 0 or 1. And really this statement is just going to return an integer. If the web application gets back a 1, it says yes, this person does exist, their credentials are correct, let's log them in. The other thing I want to point out though is that this would be a very insecure password storage mechanism. And it's bad simply because there's no cryptography applied. This statement shows that the password is just stored in plain text. So certainly no good strong cryptographic hashes for password storage, which is what we really want to see in a database. I'm showing this query here though, because it is a very canonical representation of how serious a SQL injection risk can be. But again, if this is possible, the web application has got bigger problems than just SQL injection alone. Be that as it may, let's proceed because I wanted to talk about this tautology. So what if we add our OR operator and our 1 equals 1 condition up here in the username? Now again, I've kicked it off with a single quote to close off this username string, and then I've trailed it with the -- comment syntax. Now here's the problem if this gets translated down into the SQL query. It'll look like this. So let's look at what this actually does. After username equals John Smith, single quote, close off the string, here's our tautology, the OR operator, 1 equals 1 always being true, and then everything else commented out. Now think for a moment, what would be returned by this statement? So this is a count star. Forget about username equals John Smith. That's negated by OR 1 equals 1. So what you're actually going to get is a count of the entire number of records in the users table. Now how successful this is after that will really depend on the way the application is handling the result from the SQL server. So for example, if the application is saying run this query and if the result doesn't equal 0 or if it's greater than 0, the user gets to log on as whatever username they provided. That would be a problem. This would be a serious SQL injection risk. On the other hand, if the application said, look at the result from this query, and if it equals 1, then allow the user to log in, now there's a problem. Because this isn't going to equal 1. It's going to be 100 or 100,000 or however many users are in the users table. But as an attacker, we have a little trick, and it's this. So see what just happened here? I'll go back. Here is OR, 1 equals 1. Now it's AND, 1 equals 1. So this changes the nature of the query. And now, rather than negating username equals John Smith, it's requiring username equals John Smith. So it will only return one record. 1 will always equal 1, and the username will equal John Smith. So now we're only going to get one record, and if the application is only looking for one record, then the user will be logged in. But of course, this is actually pretty verbose. So what if we just did this? Just commented everything else out. Now it's actually very simple. The only where condition is that there needs to be a user called John Smith. Password doesn't matter. Any other tautologies off the end of it also don't matter. This becomes very, very simple. But of course, there is a caveat, and the main caveat is you've got to assume that the username is going to come before the password in the SQL query. Now, it's very easy to describe how this might work when it's all pre-prepared and it's on a slide, but it's very different when you're remotely executing this attack and you've got to make assumptions about how the underlying query is written. So the or 1 equals 1 clause can actually be much more useful when you don't know the order of the conditions in the where clause, because it wouldn't matter where that or sat, it would always be true, the tautology would always work, and you'd always be logged in. The reason I wanted to show it to you this way is just to demonstrate how many semantics there can be in the execution of an attack like this. And you've really got to start to think about all the different possible ways the query might be put together based on that untrusted data from the web application. It requires a lot of trial and error, and particularly as we progress into more sophisticated attacks, a lot of background in terms of how the SQL query syntax actually runs. So this is one very good example of a malicious attack. Let's take a look at a bunch of other possibilities when you can mount an injection attack like this.